Alright, this video is the first part in solving quadratic equations. More specifically, this video is going to focus on solving equations by factoring, factor by grouping, and solving for x via the square root. The first one we go over, which is just factoring, my view is the easiest one. The example we're going to do is solve this equation, pretty much where the coefficient of x squared is 1. You have to find the factors of 2 that add to give you 3. And those factors are, of course, 1 and 2. Now, since the second sign is positive, that means both factors have the same sign. Since the first sign is negative, that means they're both negative. That means if you set each of these equal to 0, x is equal to 1, or x is equal to 2. Alright, here's another one you can solve. X squared plus 5x minus 24 is equal to 0. Now, since the second sign is negative, you need the factors of 24 that subtract to give you 5. You notice the factors would be 8 and 3. So, draw your two factors. And now, since the second sign is minus, that means they're different signs. And since the first sign is addition, that means the bigger number has the addition sign. So it's x plus 8 and x minus 3. So you take them and set them equal to 0. And x is equal to negative 8, and x is equal to positive 3. Alright, here's an example I want you to try yourselves. That's what TY stands for, is try yourself. The equation is solve x squared minus 2x minus 15 is equal to 0. Alright, since the second sign is negative, there'll be different signs. And you need the factors of 15 that subtract to give you 2. The factors of 15 that subtract to give you 2 are 5 and 3. If you're not sure how I come up with that, you can list out all the factors of 15. I think those are it, and you find which of them have numbers that subtract to give you 2. And since the first sign is minus, that means the bigger number would be negative. You can also, another way to think about it would be positive 3 minus 5 gives you negative 2, which is what we have in the original equation. So now, take each of these and set them equal to 0. So that tells you that x is equal to 5 and x is equal to negative 3. Here's an example of what I was talking about earlier about using the square root. Okay, if I give you something like x squared minus 4 is equal to 0, you just add 4 to both sides. So you have x squared is equal to positive 4. Take the square root, so x is equal to positive or negative 2. Here's another one, x squared plus 9 is equal to 0. Subtract 9, and x squared is equal to negative 9. Take the square root of both sides. You have x is equal to, since we're taking the square root of a variable, it would be positive or negative. Now, square root of 9, in case you've forgotten from the video about complex numbers. Remember, you can factor the I out, so it's I times the square root of 9. And square root of 9 is 3, so it'd be x is equal to positive or negative 3i. Yes. Here's another one. Solve 2t squared minus 7 is equal to 0. Alright. You could start off by adding 7, so you'd get 2t squared is equal to 7. T squared is equal to, hold on, no square root yet, it's just 7 over 2. That means if you do the square root of both sides, t t is equal to positive or negative square root of 7 over 2. You could leave it like that. Or if you want to get really fancy, you do square root of 7 over square root of 2. Now, I don't know if you ever had any algebra teachers teach you to never have a square root on the bottom. So I had some students last year who were all freaking out that I didn't require them to do that. So if you don't like having a square root on the bottom, you can just multiply the top and bottom by the square root of 2 over the square root of 2, like the square root of 2 over square root of 2. So that tells you the denominator would just switch to the square root of 4, which is 2. Then square root of 7 times square root of 2 is just square root of 14. Alright, here's another one. 3 times x plus 7 squared plus 4 equals 79. Now you could technically FOIL the x plus 7 squared and then get it into a quadratic equation and factor it or whatever. Or since we have a perfect square, you could actually solve it. Subtract 4 from both sides, so 3 times x plus 7 squared is equal to 75. That's what we did. Then if you divide by 3, you have x plus 7 squared is equal to 25. So now if we do the square root of both sides, you have x plus 7 is equal to either positive 5 or negative 5. So if you solve both of these for x, you should have that x is equal to negative 2 if you solve the first one, and then negative 12 if you solve the second one. Here's one I want you to try on your own. Solve 2 times x plus 6 squared minus 9 is equal to 63. Alright, we need to get rid of the minus 9. So the way you do that is by adding 9. So 2 times x plus 6 squared is equal to 72. And then if you divide by 2 on both sides, you have x plus 6 squared is equal to 36. And now, if you take the square root of both sides, you should have two separate equations to solve. Both x plus 6 is equal to 6, and x plus 6 is equal to negative 6. If you solve both of these for x, x will be equal to 0 or negative 12. Alright, here's an example of when you could do what we call a factor by grouping. Alright, if you have 2x squared, that's supposed to be a 2 next to the first x. 2x squared, and I just made it worse. Just know that that's supposed to be a 2. 2x squared plus 19x plus 24 is equal to 0. You multiply the leading coefficient by the constant 2 times 24, which is 48. Now find the factors of 48 that add, since the second sign is addition, add to give you 19. Now if you want to list the factors out, the factors are 1 and 48, 2 and 24. Neither of those add to give you 19, but 3 and 16 do. Now, that means we can rewrite 19x as just 16x plus 3x. And you have your plus 24 and your plus 2x squared. And I still can't write on this thing. Now, the reason we do that, the reason we call it factor by grouping, is because you group the first two terms together and you look to see what you can factor out. They're both divisible by 2 and by x, so if you factor 2x out of the first, you're left with x plus 8. Then for the second two terms, they're both divisible by 3, so if you factor a 3 out, you still have x plus 8 again. Now since both of these terms have an x plus 8 in common, if you factor out the x plus 8, you're left with 2x for the first term after you factor out the x plus 8, Now after you factor out the x plus 8 out of the second term, you're just left with 3. So now, if you set both of these factors equal to 0, alright, you should have the x is equal to negative 8 for the first one, and then if you solve the second one for x, you should have negative 3/2. Alright, now if I tell you to solve this one by grouping, by the factor by grouping, multiply the leading coefficient and the constant, so that's 120. We need to find the factors of 120 that add to give you 29. So, the factors of 120 that add to give you, or the factors of 120 period are just 1 and 120, 2 and 60, 3 and 40, 4 and 30, of course, 5 and 24. Oh wait, there are two factors that add to give you 29. So we can rewrite our quadratic as just 4x squared plus 24x plus 5x plus 30 equals 0. Let me separate so I can have room to work now. Now for the first two terms, after you group them together, you notice they both have a 4 in common, they both have an x in common, so if you factor out a 4x, you're left with x plus 6. And for the second two terms, they both have a 5 in common, so if you factor out a 5, you still have x plus 6. So now if you factor out the x plus 6, you're left with 4x for the first term and 5 for the second term. So now if we solve for x, or if we set both of them equal to 0, you should have x equals negative 6, and if you solve the second equation for x, you should have negative 5/4 as your answer. Yeah, I want you to solve this one on your own. Alright, if you start off multiplying the leading coefficient and the constant, you have 16. Factors of 16 are 1 and 16, 2 and 8, and 4 and 4. The factors of 16 that add to give you 8 are 4 and 4. So you can rewrite our quadratic as just 16x squared minus 4x minus 4x plus 1. So now if we factor by grouping, if we factor a 4 out because they're both divisible by 4, and if we factor out an x out, we're left with just 4x minus 1. And if you factor out, I believe it's just a minus 1, so we can get this first term positive. If we factor a minus 1 out, negative 4x divided by negative 1 is just positive 4x. Then negative 1, or positive 1 divided by negative 1 would just be minus 1 again. That's still equal to 0. So if you factor the common factor, the 4x minus 1 out, you're left with 4x minus 1 again. So, since we have the same equation, you only have to solve it once, obviously. So x would be equal to 1/4. But remember, since the same root appears twice, it has a multiplicity of 2. I mean, we'll go over this part more, the multiplicity of 2, later. It's just something to note for now.